So in this video we're going to find the volume of a sphere of radius r, and then we're going to evaluate it to see if we get the volume formula. So imagine looking at the side of a sphere. So now we've got a three-dimensional object. Here's our center, and it's got a radius of r. Okay. Well, what we're going to do is we're going to cut a slice, and basically the slice could be anywhere in the sphere that we want, and it's arbitrary, but because of where I drew the r, I'm actually going to have the slice go through that r. So imagine that slice, you take a tennis ball or a baseball and you slice it like that, what that would look like. And we're going to give it a little bit of thickness here. So it is going to be three-dimensional. And here's the center of that slice. That's going to go out there. Now we need to give some dimensions here, and that center of the slice is some distance above. So let's give this thing a thickness of dx. That would make this side x sub I. That's some arbitrary height that our slice is above or below the center of the circle. So x sub I can be anything in that range. And we want to give this guy a dimension also. And we can give it any name we want. Let's do maybe y sub I. Goes with x real nice. That's that distance from the center of our slice to the edge of the circle. Now, what we're going to do is we're going to start with the volume of the ith slice. Now, if you can kind of imagine what that shape would look like, we're cutting it so that we can assume the sides are flat. Therefore, it's going to be basically a cylinder. So the volume of a cylinder is going to be pi times its radius, which we called y sub I, so times y sub I squared, and times its height, which we've called dx. And so we got pi y sub I squared dx. This is a nice starting point, but what we want to notice right away, these variables don't match. We want to get a relationship between y sub I and x sub I, so that's our next goal. Well, you can see in my drawing, I've got a right triangle with r, which is a constant, that's why there's no sub I on it, as the hypotenuse. So I know x sub I squared plus y sub I squared equals r squared. And we want to sub in x and sub out y, so we just solve this for y sub I squared. We don't need to take the square root like we might on the area of a circle, because y sub I squared is actually what I want to sub for. So when I sub, what this is going to look like is pi times r squared minus x sub I squared dx. Now I'm going to turn this into a definite integral. I like writing the pi out front because it's just a constant. R squared minus x squared dx. Sometimes you'll see parentheses around that. Notice I've dropped the sub I. It's because now I'm in the continuous case, not the discrete case. And now I just need limits. Well, I'm going to, the lowest possible slice is down here at a length of negative radius from the center. And the highest possible is all the way up here at a positive r, because remember, those are constants as far as this guy's concerned. This ends up not actually being a bad integral. No special substitutions needed or anything. So let's just go ahead and calculate this. Remember, r squared is a constant, so I'm not going to do this. I'm not going to have r cubed over 3. I'm going to have r squared times x, because of constant times my variable. Basically looking at the antiderivative of a constant. Now here we'll have x cubed over 3 and negative r to r. If you did r cubed over 3, what you'd see is your answer won't come out quite right, although it's very close and it's very deceiving. So pi, let's put in our limits. So I've got, basically when I put that in, I'm going to get r cubed minus r cubed over 3. There's my upper, minus negative r cubed minus negative r cubed, because it's an odd power, over 3. And I'm going to leave the pi out of it for right now. So let's see how this is going to play out. So I'm going to have r cubed minus a negative r cubed. So plus r cubed minus r cubed over 3. And check this out. I'm going to have minus, minus, minus. So 3 of them is going to keep it negative, so minus r cubed over 3. Alright. Give these guys a common denominator, and we'll finish this off. This is going to be 3r cubed over 3 plus 3r cubed over 3 minus 1r cubed over 3 minus 1r cubed over 3. So, 3 plus 3 is 6, minus 1 is 5, minus another 1 is 4. So we have pi times 4 r cubed over 3, or there is the volume of a sphere of radius r, 4/3 pi r cubed.